Um, Assalamualaikum and have a good day. My name is Nurisa binti Misban. My entry ID is SA22006. So today I will be presenting my assignment with the title of Synthesizing Graphene Oxide as a Working Electrode using the Cyclic Voltammetry. This is the overview of the research, which consists of the background of the study, problem statement, methodology, result and discussion, and lastly, the conclusion. Moving on to the background of the work, graphene oxide (GO) is an oxidized multilayer of graphites that are synthesized via chemical reaction with potassium permanganate, which introduce oxygen functionality that expand layer of separation and render the material hydrophilic, in which facilitating the facilitating the exfoliation into single or multi-layer graphene sheets through the sonication in water. And while the GO's dispersibility in water and other organic solvent is advantageous for enhancing the electrical and mechanical properties, but when mixing it with the ceramic or polymer matrix, it disrupts the sp2 bonding networks due to its oxygen functional group, which classifying it as the electrical insulator. And voltammetry, particularly the cyclic voltammetry (CV), is a powerful electrical analytical technique for studying the redox process and reaction intermediates, offering the benefits in minimal sample preparation compared to other methods. And the carbon paste electrode are widely used due to the broad potential range and cost effectiveness, and their performance can be enhanced by modification in advanced material. This is the problem statement of the study, which is the aim of the study is to compare the electron transfer capability within the electrodes. This comparison is used to determine the optimum condition for our working electrodes. And the last problem statement, which is the research specifically seeks to compare the working electrode effectiveness of a graphene oxide electrode against a carbon phase electrode in common usage. Moving on to the methodology, for the methodology of cyclic voltammetry and characterization, the first one, the composition of working electrode was prepared by mixing the synthesized product and organic glue paraffin in an 8:2 ratios. Secondly, the subsequent tests use cyclic voltammetry with a deposition time of 10 seconds and a scan rate of 300 millivolt per second. And the sample solution for the condition test was an alkaline solution with a pH of 9. Moving on to the result on discussion, these results are for the voltammogram analysis for coefficient diffusion of working electrode. Figure 1 shows the voltammogram at optimum condition, and figure 2 shows the varied scan rate at pH 9 and optimum condition. So from these two figures, the optimum pH of alkaline water is pH 9, and the test has been done on optimum composition of electrode 8 to 2 in scan rate 100 millivolt per second at deposition time of 10 second, and the peak result of pH 910 at low level, and there are no sharp peak while scanning from towards current to the back current. And the result of this figure 2 has been shown in the table 1 below. This is the table 1. And it shows the varied scan rate at optimal conditions. The scan rate are set from 100 to 300 millivolt per second, and these are the result. So by the following data, we can calculate the coefficient diffusion for the highest value of varied scan rate using the Randles-Sevcik equation. This is the equation right here. And from this equation, the result of the calculated coefficient diffusion of each varied scan rate are shown by the table 2 here. This is the table 2, the coefficient diffusion of varied scan rate, also from 100 to 300 millivolt per second. And we can see the difference between two. It shows that from the scan rate 100 to 300, it's getting smaller in value. So by comparing with the carbon paste electrode, GO phase electrode can be proven to be better for conductivity based on the voltammogram result. And the following result in the comparison between carbon paste electrode with GO phase shown by the figure 3, and followed by the voltammogram data shown by the table 3. So here are the figure 3, which shows the comparison between carbon paste electrode with the GO electrode. We can see the red voltammogram is for the GO, and then the black colored one is the voltammogram for the carbon paste. And table 3 here shows the voltammogram for comparison of electrode. The top one is for carbon paste and the lower one is for GO paste. And from there we can conclude that this research conclude that graphene oxide can be effectively used as a working electrode, and its superior performance in conductivity indicated by the coefficient diffusion, which demonstrated it enhanced the electron transfer activity. And here's are the reference of the journal, and that is all from me. Thank you.